17.6, the first reaction we're going to take up is the reaction of an alcohol with SOCl2 or PBr3. And these reagents convert them to alkyl halides, either the chloride or the bromide. The scope and limitations here are that this is primary or secondary. We don't need these reagents for tertiary. Remember, tertiary alcohols with hydrochloric acid or hydrobromic acid will go through an SN1 mechanism. These are SN2 reactions, which means we can use that for chirality interconversions. That's an important point for us to realize. So now let's look at a specific example. We'll take a chiral phenethyl alcohol. If we treat this with thionyl chloride or tribromophosphine, and we'll start with SOCl2, we produce, since it's an SN2 reaction, an inversion of configuration. Now, how does that occur? Well, I'm not going to push the arrows in detail. You can go and practice with those. But the alcohol is converted to this chlorosulfonate, which is a good, oops, I have an atom missing. Let me put that atom in. So put that part out. So the alcohol is converted to this chlorosulfonate, which is a good leaving group. Of course, when that happens, we have a chloride floating around in solution. And if you remember the mechanism of SN2, it has to come in 180 degrees from the leaving group, and that gives us the inversion of configuration for the production of the alkyl chloride in this case. All right, and a similar intermediate obtains just with the phosphorus oxygen displacing the bromide for PBr3. All right, so that's the first one, the interconversion to the alkyl halides. Now, we can also, in a multi-step sequence, convert alcohols first to the tosylate, all right, let's cut this out. I'm not getting good writing out of my pens today. Okay. For the tosylate, you do that with tosyl chloride and a base, some sort of tertiary amine, either triethylamine or pyridine in this case. We can then react that with a nucleophile, for instance, a carboxylate, and convert the alcohol to an ester. This first step replaces the hydrogen with the tosylate group, and that converts a compound where the RO, or the carbon-oxygen bond, is not reactive or displaceable into something where it's a good leaving group. Tosylates, these sulfonates, are what are referred to as pseudohalides. So these pseudohalides react like alkyl halides. They'll undergo an SN2 reaction with a wide variety of nucleophiles. And again, I'm not going to be able to show you everything in lecture. You need to go and practice the problems. Now, tosylate, I said it's a sulfonate. What's the structure of this? It's paratoluene sulfonate. Okay. So the chlorine is a good leaving group. It reacts with the alcohol on pairs here. So first step, we're replacing the OH bond. This bond, which was not displaceable, now becomes displaceable because this is a pseudo halide, and we can do lots of interconversions with that. So we can take a chiral alcohol again, we react it with tosyl chloride and triethylamine. Now, let me draw this out. I want you to see the similarity to the intermediate that we produced with thionyl chloride and with tosyl chloride. We've made this sulfur or sulfonate oxygen bond, and that makes this bond now something that we can displace. So for instance, we could react this with sodium acetate, and we would get inversion of configuration because of the SN2 reaction. So both of these, well, you already know about the reactivity of alkyl chlorides and alkyl bromides as electrophiles for nucleophilic displacement. And what we've added to that is that we can convert an alcohol to a tosylate. This is a very high efficiency reaction. Yields can easily get, well, conversions are 100% typically, and yields can be almost that high. And then these are pseudohalides and allow us to do the displacement using appropriate nucleophiles.